Hello friends, welcome to another practice question of Arithmetic Progressions. This is the 35th question in the series. I will strongly urge you to go back and watch the previous 34 as well. The link to the entire playlist is down there in the description for your reference. Okay, this is a higher order thinking skills question. It says there are 2n plus 1 terms in an AP. Prove that the ratio of the sum of the odd terms and the sum of the even terms is n plus 1 is to n. Okay, so let's say we find the sum of odd terms on this side and the sum of even terms on this side. Okay, sum of even terms. Okay, so we know that uh, there are 2n plus 1 terms in the AP. Okay, so the AP actually is represented as A1 plus A2 plus A3 plus A4 so on till A of 2n plus 1 terms. So these are the odd terms, and the odd terms are n plus 1 in number and the even terms are n in number. Okay, so the sum of the odd terms will be S of 1 is equal to A1 plus A3 plus A5 and so on till A of 2n plus 1, and the common difference for this will now become 2d, because if the original AP had a common difference of d, the sum of odd terms AP will have a common difference of 2d. So the sum will now become S1 will now become we have n plus 1 terms, n plus 1 by 2 multiplied by the sum of the first term, which is A1, plus of the sum of the 2n plus 1th term. Okay, sum of the first term plus the sum of the 2n plus 1th term. Now the 2n plus 1th term is, let me substitute that value here. This is n plus 1 whole thing divided by 2 multiplied by A1 is A. Let's assume that the initial uh, number is A. Okay, the first term is A. The second term, the last term will be A plus 2n plus 1 is the nth term right now we are playing with is 2n plus 1 minus of 1 into d. Okay, this. Now on solving it further, what we get is n plus 1 by 2 multiplied by 2 times of A plus, this is 2nd because this will get cancelled, this is 2nd, so it will be A plus nd. Okay, and this 2 will cancel this 2, so the final answer for sum of odd terms is n plus 1 into A plus nd. Okay, one part of the question. The second part of the question is the sum of even terms. So S of 2 is equal to A2 plus A4 plus A6 so on till A of 2n. Now S of 2 will be equal to n by 2 multiplied by A2 plus A of 2n. N by 2 will remain n by 2 multiplied by A2 becomes A plus d, and A of 2n will become A plus 2n minus 1 into d. Okay, A plus 2n minus 1 into d. On solving this further, you get this will be n by 2 multiplied by 2a plus d plus 2nd minus of d. So the d gets cancelled with the d, and I take the 2 out common. That 2 will cancel this 2, which is this 2 will cancel this, both the 2's. So I get n into a plus nd. Now the question becomes very simple. I have to find the ratio of the sum of odd terms and the sum of even terms. Okay, so this was my S2 till now. Now the final answer is actually S1. divided by S2. S1 is n plus 1 divided into A plus ND. The whole thing divided by n into A plus ND. A plus ND gets cancelled and I finally get S1 upon S2 is equal to n plus 1 upon n. And this is the solution to the question. This is what we actually set out to prove. I hope you found the solution useful. Do like, share, comment and subscribe. And in case you want me to solve any other questions for you, do put down your queries at the WhatsApp number mentioned in the description. Till then, keep working hard, keep practicing hard. Cheers and God bless.